Hello, Matthews Gatos here. In this video, we're going to cover applications of trig derivatives. We're going to split this into two videos, type 1 max-min equations, type 2 related rates. So in this video, we're going to talk about max-min questions. So here's the steps that I recommend you follow. First thing is I want you to write one equation with one unknown fully simplified. So the more simplified your original function is, the easier your derivative is to take. Now we want to have our function in terms of a theta so that we can use our trig derivatives. So once you have one equation, you're going to take the derivative of that equation and find the critical values. That's the derivative equation set to 0. Once you've done that, you want to verify that it's a max or min. There are two ways of verifying. First way is with the first derivative test, setting up intervals and showing if it's increasing on one side, decreasing on the other, you have a max, or vice versa. If you are decreasing on one side and increasing on the other, you would have a min. The other way of doing that is with the second derivative test. So the second derivative test, we take the second derivative and substitute our critical values in to see if it's positive, concave up, having a min, or if it's negative, concave down, having a max. Then once we've done that and verified it, we can substitute our critical value into the original equation and find the needed max or min value, because that is a y value. Okay, I have two examples for us to do. Let's look at our first one. So in this one it says find the maximum perimeter of a right triangle with a hypotenuse of 20 centimeters. So I want to find the maximum perimeter. So the perimeter is equal to 20 plus x plus y. Now I have two variables there, so I'm going to have to rewrite in terms of theta, and I'm going to go back to my triangle to do that. So back to my triangle, and if I look at theta, this side here would be opposite, this side here would be adjacent, and this side here would be hypotenuse. So let's write the cosine of theta, which is adjacent over hypotenuse. Multiply both sides by 20, and 20 cos theta is equal to x. Let's do the same thing for sine. So sine of theta is equal to opposite over hypotenuse. Multiply both sides by 20, and I get 20 sine theta equals y. So now that I have x and y in terms of theta, back up to my perimeter question, and I can write this as 20 cos theta plus 20 sine theta instead of y. So now that I have one equation with one variable, and that variable always we want to be theta, I can now take the first derivative. So the derivative of 20, of course, is 0. The derivative of 20 cos theta is 20 times negative sine theta. Remember, your c value trig functions have a negative derivative, plus 20 times cos theta. So what I really have for my first derivative is negative 20 sine theta plus 20 cos theta. So now that I have my first derivative, I want to set it equal to 0 to find my critical values. Okay, so what I'm going to do is I'm going to add 20 sine theta to both sides, and then divide both sides by 20. Now, you can't ever divide both sides of an equation by a variable. So I can't divide by a variable, although it looks tempting, I can't do that. So I just need to kind of know my unit circle and know where is sine and cosine have the same value. Well, I know the points on the unit circle where sine and cosine are identical is pi over 4. That has coordinates of root 2 over 2 and root 2 over 2. And I also know 5 pi over 4 has coordinates negative root 2 over 2 and negative root 2 over 2. So it has to be one of those values. In terms of a triangle, I can't have an angle of 5 pi over 4. That's too big. So I know that the only solution that makes sense to this question is having pi over 4 as my solution. So now that I know that's my critical value, I have to verify that it is in fact going to give me a maximum. So two different ways that I can do that. My first way is going to be by using the first derivative test. So my first derivative was negative 20 sine theta plus 20 cos theta. So to look at my first derivative test, I'm going to set it up with pi over 4 in the middle. Obviously 0 would be the lowest. And we're going to look using values on our unit circle. So I'm going to use points below pi over 4. So I'll use pi over 6, which is below. And I'll use pi over 3, which is above. So pi over 6 has coordinate root 3 over 2 and a half. And then pi over 3 has coordinates of 1/2 and root 3 over 2. So I'll use that for my derivative test. Okay, so to the left of pi over 4, I'm going to use pi over 6. So negative 20 times sine. Well, you can see that sine is a half. So negative 20 times a half is negative 10. Plus 20 times cosine. Well, cosine is root 3 over 2, so 20 times that would be 10 root 3. So you can see that because it's a 10 root 3, that's bigger, so it will be positive. Positive meaning it's increasing. Now testing above pi over 4, I'm going to use pi over 3 to test. So I'm going to have negative 20 times sine. Well, the sine of pi over 3 is root 3 over 2. So that will be negative 10 root 3 plus 20 times cosine. Cosine is a half, and that would just be half of 20, which is 10. So you can see that the negative number is bigger, so it is decreasing. So I have verified that this is in fact a maximum. Okay, the second way that you can verify that is with the second derivative test. And I'll show you that method in the next question. So now that I know that pi over 4, theta equal to pi over 4, gives us a maximum, we need to go and figure out what the maximum perimeter is. So you'll remember my equation for perimeter. It was 20 plus 20 cos theta plus 20 sine theta. So let's just plug in what theta is to figure out what our maximum perimeter is. So cos of pi over 4 plus 20 times sine of pi over 4. So this is going to be 20 plus 20 times root 2 over 2 plus 20 times root 2 over 2. So 20 plus 10 root 2 plus 10 root 2. And just grouping my like terms, it would be 20 plus 20 root 2 centimeters. That would be my maximum perimeter. Okay, my next question here, we want to determine the maximum area of an inscribed triangle with a diameter of 40 centimeters. So this would be 40 centimeters. This will be my angle, and I could use either angle. I'm using this angle here because I'm looking at area base times height. So this is the base, this is the height. So you can use either angle and your answer will be the same in the end. So for this one here, I need to come up with my formula for area. So area is equal to base times height divided by 2. So you can see looking at this, I have two variables, neither of which is theta. So I need to go back to my triangle and use some trig ratios to rewrite base and height in terms of theta. So over here, the way that I've drawn my triangle, I see that from theta, this is the opposite side. Of course, 40 will always be the hypotenuse, and the height is my adjacent side. So looking at sine, sine of theta is opposite over hypotenuse, times both sides by 40, and I get 40 sine theta equals b. Then looking at cosine. So cosine of theta is adjacent over hypotenuse times both sides by 40, and I get that height is equal to 40 cos theta. So now in my area formula, I'm going to use, instead of b, 40 sine theta, and instead of height, I'll use 40 cos theta. and that will all be divided by 2. Okay, so what I end up having, 40 times 40 is 1600 sine theta cos theta divide by 2, which is just 800 sine theta cos theta. So now that I have my formula, I'm going to take the derivative. Now, I could take the derivative just like this, or remember my tip, if you can simplify your original function, it makes the derivative easier. So if I were to take the derivative right now, I would have to use product law. But anytime I see sine and cosine multiplied together, I always think of my sine double angle identity. So I'm actually going to rewrite my original function like this. 400 times 2 sine theta cos theta. So just factoring out of 400. And then you'll recognize 2 sine theta cos theta from your formula sheet as a double sine angle identity. So this is just the same as sine 2 theta. Now, I don't know about you, but I think that would be much easier to take the derivative of. So let's take the derivative of our new function. So the derivative is going to be 400 times. Now the derivative of sine is cosine, but it's not just sine of theta, it's sine of 2 theta. So I also have to multiply it by the derivative of the angle. So the derivative of 2 theta is just 2. So that means that my first derivative is 800 times cos of 2 theta. So we're going to set that equal to 0 and solve. So setting it equal to 0. And then I want to solve. So the first thing that I'm going to do is divide both sides by 800. And then I get cos of 2 theta is equal to 0. So 2 theta is equal to any time cosine is equal to 0. Well, cosine is equal to 0, and if you think on the unit circle, that's where the x coordinate is 0. So there are 2 points on the unit circle where the x coordinate is 0. Pi over 2 and 3 pi over 2, which is 0 and -1. So that means that 2 theta could be pi over 2, or 2 theta could be 3 pi over 2. Now, we don't want to know what 2 theta is, we want to know what theta is. So divide both sides by 2, and I get pi over 4, or divide both sides by 2, and I get 3 pi over 4. Okay, now this one's too big to be in the triangle because I already have pi over 2, so this is too big. So I know that the answer that is going to give me a maximum area is pi over 4. So I want to verify that it will give a maximum. On the last example, I used the first derivative test, so I'd like to use the second derivative test so you see another way you can verify. So looking at our first derivative, it's 800 cos of 2 theta. So let's look at my second derivative. So taking the second derivative, it's 800, and then the derivative of cosine is negative sine, so negative 2 sine theta, and the derivative of theta is 2. So altogether, this will be 1600, negative 1600 rather, sine of 2 theta. So now that we know what our second derivative is, all we have to do is plug in our angle to see if it's a positive or a negative. So if I plug in negative 1600 times sine of 2 times theta, so this will be negative 1600 times sine of pi over 2. Now, sine of pi over 2 is 1, so this whole thing is just negative 1600. So since the second derivative is negative, that means it's concave down like a frown, which means that we have a max. So we've verified that we have a maximum at theta equal to pi over 4. Now all we have to do is figure out what our max area is. So back to my area formula, which was 400 sine of 2 theta. My max area is going to be 400 times sine of 2 times pi over 4, which is 400 times sine of pi over 2, which we already saw was 1. So that means my maximum area is 400 centimeters squared. Okay. Speaking of area and perimeter, what did area say to perimeter when they were in an argument? I'm trying to talk to you, but I feel like you're just going around my problem. Thought that was pretty cute. Okay, so to practice this concept or these types of questions, which are the max-min questions, you guys can complete your homework. I hope this video helped you, and I look forward to seeing you for the next one.